have a presentation. It was something I sought some expert opinions on GIS for indoors. You all requested that as a future presentation, and so we have some fantastic folks from Michael Baker International and Datamark to give us a presentation on data collection and use cases around indoor mapping. It's definitely a hot topic within 911, but also, you know, I know that a lot of counties are having to create indoor maps for school safety, etc. So I'm going to stop sharing and hand it off to Matthew. Matthew, are you with us?
I am. Thank you.
Fantastic. Thank you for joining us and giving us a presentation today.
Sure. Can you guys see my screen?
I can.
Perfect. So yeah, I wanted to first say thank you for this opportunity. My name is Matt Dondanville. I'm with Michael Baker International, and then we have a division called Datamark that does 911, NG 911 GIS work that includes indoor mapping and road center lines. Michael Baker International is a 4,000 person engineering firm that does, I think we have a couple hundred GIS professionals. But my background is I actually came to Datamark about a year ago from Esri, and at Esri I ran the 3D Technical Center, and then that's kind of precursed by being in the data science department, and then also working in the routing and optimization team, and that was all in professional services. This meeting today really excites me because everything from LiDAR to petabyte storage of 3D data and imagery and deep learning and extraction, that was all under kind of the work that I did. So great work to everyone on this call and the cool stuff that you're doing. I worked with different areas in Arizona, but a lot of probably most states by now in these roles, and every state's doing stuff a little different, but certainly doing very cool things. Indoor mapping fell a little bit under 2D and 3D, so the 3D Technical Center ended up seeing a lot of that work, and I did a lot of R&D around indoor mapping. Did projects for pretty much every market that you can think of, and really saw a lot of different use cases. And so today, really want to make it really generic, welcoming any questions about different use cases. They're more from they're from Datamark's side now, which is a lot of public safety, and the reason I came over is to take indoor mapping and try to scale it on the collection side and then the dissemination side, but also a lot of projects and experiences that I've learned over the years. Indoor mapping is kind of the next frontier. I assume, being a landlocked state in Arizona, that ocean mapping is not on the forefront of everyone's mindset. That's kind of also the other unexplored frontier. These are the areas that we can't really get to just with satellite or plane-based imaging. So it's been around for a while. Michael Baker was doing indoor mapping with total stations and a sensor being carried with they were doing radiation surveys inside buildings, but obviously it took a long time. We're getting to the space now that it's becoming fast enough and the dissemination products are there that it's getting into the hands of everyone. And so this is really enabling different workflows. Like I said, indoor mapping's been around, and everyone probably on this call has a different view of it. Everything, it's really roots down to the idea of a digital twin too. It's really hard to define what that is because there's different standards and meanings to everyone. There's different use cases. Some people are looking at indoor mapping for asset management. Some people are looking at public safety. Some people are looking for high quality, high level of detail for referencing precise measurements. Some people are just looking for reference. There's use cases from the insurance agency and just documenting indoor spaces in case something happens. And then there's the relationship back to what we've been doing with indoors for the last 20 to 30 years, and that's CAD data. In an engineering firm, engineers have been doing indoor mapping, quote unquote, since the beginning of time, drawing indoor spaces. But digital CAD and BIM models have, in kind of the marrying of that space to the GIS world, is all culminating. Like I said, there's a lot of different use cases. I've been part of a lot of these different use cases. Right now, my focus is a lot on the public safety side, how to map things at scale, instead of it taking months and months to capture one building, how to do it in a matter of hours, how to put data in the hands of the people that need it, and then also how to maintain that data. One thing I'll talk a lot about today is that this data, everyone here is geospatial, and we have a lot of roles and responsibilities already. We're getting asked to look into indoor mapping, but we're not the building owners. We don't know these spaces intimately, and so it's really hard to maintain that data, especially if it always has to come back through us. We're kind of a choke point. So figuring out strategies to make sure this data is first off collected right, and then able to be updated in an easy way. Obviously, space planning and hoteling, that's Esri's big push around indoor mapping, asset inventory, floor aware assets, cameras, other things. Like I said, the insurance industry is really looking at it. Industrial design, everything. I've seen projects with OSHA safety, looking at clearances, how to fit new equipment, and what are the pathways between equipment, bringing in equipment in both 2D and 3D, and looking at space planning. Wayfinding is a really great use case for a lot of different markets, and can be implemented a lot of different ways, from beacons to cellular technology. How do you route people in indoor spaces? I've worked on some big hospital projects around this for patient experience, and there's some really cool use cases. RF design and cellular design and auditing. This is another space. And then obviously, we're pretty familiar, if you've been to a bigger conference, a lot of conferences and in larger event spaces are doing things around event planning. I'll fly through these, kind of talking about these. I want to really make sure that we have a lot of time at the end for questions. But really, the reason I've fallen into a lot of these different use cases are because people come up with, you guys come up with the most interesting use cases. You guys know your workflows and what can be improved. And the integrations and what we can do is really limitless with this new technology. One use case I did want to highlight is a county in Maryland that I currently work with that has really embraced this. Throughout this presentation, I'm going to talk about dual use of data. Dual use, I mean, right now I'm wearing a public safety hat. This county in Maryland has collected over 40 buildings with various use cases. And they have a public safety hat on. but the PSAP, the answering point, the fire, the police, they don't know these buildings intimately. And so it's really a kind of a public and public-private partnerships to be able to access these buildings, get the funding needed, and then to use this data. And so the different stakeholders are using the same data model, the same data models feeding into the 911 centers, into the police and the fire, but can also be used for things like asset management for the school district. And so we'll talk about standards here and kind of some of that that data model. Kind of the big topic is, where do we start? So, like I said, from the people typing in where they're from on this call, it's quite a broad list, and I'm sure everyone is familiar with different parts of these different input technologies and data inputs. And so we'll go through those. And so we have data like BIM. BIM is kind of the newer type of data and is great for kind of these newer buildings that are coming in and can be converted and then turned into quote unquote digital twin or for asset workflows or inspections. BIM is usually pretty good at turning into indoors data because it's a newer technology, and so it's going to be up to date. The next one that we have is CAD. CAD data is can be a great source of data for indoor mapping, but it can also be really bad. Depends on how they made the CAD data. If you're actually working off the raw source of the CAD data, or if it's really just a PDF. And then in the public safety industry, and really probably a lot of industries, how up to date is it? Things change over time. The simple idea of that is, like in a school, the rooms change all the time. So the simple attributes on the rooms are going to be different. That can be corrected. You can go in after the fact, but things like walls and geometry, and then how detailed the CAD is. These are all factors that make good or bad CAD. Also, what sections of CAD you have. Do you have the assets that you want? So in public safety, a use case is, hey, we want to see fire extinguishers and AEDs. That data is not often on kind of the main CAD data that we get. And so you're not getting all the assets. So it really depends on the use case that you're looking for. Same thing with if you have a asset management or facilities management use case, is the data in the raw CAD that you want. Sometimes it can be a starting point. Sometimes it's not worth the time. So really there's a lot of different ways to go about this, and it's not a simple answer with CAD. Paper blueprints, like I said, sometimes these are derived off CAD, sometimes they're ancient, actual hand-drawn. A lot of times the schools, I think we found blueprints that are water stained from the late 1800s. They're out of date, they're stained, they're just hard to work with. So sometimes we go down this path of, all right, yes, we do have data. Is it really worth it, or should we go out and collect? And that collection part is really what I've been working on a lot. The principal map's another one. Again, depends what the level of detail is. Can you go in and digitize over aerial imagery and get a general sense of where rooms are and keep that as a starting point? Yeah, and that might work for different situations. And so if we don't really have anything, or we don't trust the data that we have, where do we start? And this is kind of my background. So everything from manual data collection to SLAM LiDAR. And we have a couple SLAM units that we go out. And the key here and kind of overall is, per use case, there's different level of details that you might want. And so I usually drive that down to public safety grade versus engineering grade. Public safety has a mindset of indoor mapping of we need to collect things fast, and we need decent accuracy, but we don't need millimeter to centimeter accuracy. We don't need to know if that's a 36.5-inch door versus a 36-inch door. That's not really the point of that data for public safety. Public safety is more like how fast can we map all the schools to get them in a spot that 911 can use them for what they need. And then if there is a change, how fast can we fix that? Can we update the attributes? Can we change the geometry? We don't have to go back in with a specialized piece of equipment to go make little updates that take time. But there are a lot of indoor mapping use cases that something like LiDAR is great for. If the facility's master plan has a renovation and you want to go out and kind of take the LiDAR of the space now and then use that for planning or quantities, or just really precise asset management, those are great use cases. Same thing if I say a project about user experience in a hospital. Figuring out the level of detail that you really need. Do you need to map out each side of the wall and show the wall separation representation that it's a 4-inch wall in your indoor model? Is that necessary? It really depends on the use case. And so a lot of times when we go in, for example, the county with a lot of different buildings, we use a combination of many different collection techniques. Some schools say, hey, we got projects planned. We want to get the higher level of detail. We can use it for engineering, planning, quantities. Some say, hey, we're really just focused on using this for public safety and asset management. We don't need the LiDAR quality. It's a learning process. So public safety grade data is not necessarily bad. It's just different. We're not saying it's going to be like feet off, but there's different techniques. I've even seen people, people go out and collect by hand with tape measures and laser tape measures. Obviously it takes a little longer, but you don't have the equipment cost. So there's no wrong answer. Like I said, recently, the one that I've been working on is this public safety grade, and using consumer grade sensors, and then really focusing on kind of the AI and the extraction, those kind of tools to collect at scale. And so we're getting to the scalability now in the industry that you can go into a 300,000 square foot building and collect in 3 to 4 hours. And so this rapid collection is both collecting the new data fast, but allowing us to go in and do updates really quickly. With the 360-degree camera, or even a lot of the LiDAR sensors, you can go in and easily capture assets as well. You can extract those out. You can extract the floor plans, draw the walls off the processed imagery, which turns into a point cloud, or off LiDAR point clouds themselves. One interesting, we'll see if that plays, but a lot of what we see here as well is when it comes to it, that the floor plans are really just the starting point. Floor plans for a school can just show square walls to a classroom. Won't show that there's closets in the back of the classroom, or maybe a teacher's desk where that is. Sure, it can all be drawn out, but that also takes time. And so again, that goes back to the level of detail. So sometimes augmenting that data with things like imagery, seeing in here the imagery in the room. You can see, like in the cafeteria here, you can see that there's lunch lady carts. So in public safety, that's really good to know. Overlaying things like CCTV cameras is popular. Other real-time data. things like your fire extinguishers or lights. In the asset management world, there's deep integrations with asset management software there. I know TRIRIGA and some other Esri partners have really great asset management type integrations. And so I want to kind of talk about considerations here. This idea of this accuracy, what level of accuracy you need. Obviously, I love LiDAR. I've worked in the industry for a long time. It's great, but it comes at a cost. It's big data. It's harder to process. It's more expensive for the equipment, and it's not always needed. And so gauging what you need for your project, and then who is the end user? It could be multiple people, and maintaining those relationships. Like I said at the beginning, as a geospatial person, either all this is going to fall on your shoulders and you're going to get calls constantly with changes. The data is not going to get updated. It's really a partnership to work with the building owners. If it's the district facilities people, if it's the apartment owner, if it's the hospital, security or maintenance, or working to get easy update tools in the hands of the building owners is also a use case that we found. Planning for the future. Like I said, in the public safety world, we're focused on the massive buildings, as many as we can. In something like a hospital example, we're focused only on our building. I've worked with corporations, they care about their campuses. So 10 or 15 buildings. It depends how scalable we need to make it. Are we going for collection in the masses or collecting a few buildings? And there's different ways to go about each of these. Different levels of detail that we want, different attributes that we want to maintain. Everything that I've said, and obviously with my background, is quite largely Esri focused. In like most states, I know a lot of the people on this call are Esri users, so that probably relates well. They focus their tools, their data model on, well, the tools are growing a lot of space planning and management, and then extending with kind of your individual use cases, but it's really based on a data model. To be honest, we are a partner of Esri's. We make tools for public safety that are built off the indoors data model, and really makes it easy for non-GIS people to maintain the data, and then it gets it into the call handling, the CAD systems, and then gets it into the police and fire's hands, and then it's kind of a middleware, so they don't have to log into a different system. And so that's what we do. But really, that Esri data model, singular data model, can be used with many different systems, many homegrown systems. There's customers that we have that use some of our products that they want to use it for public safety. They also use that same data model and use it for asset management, just with the ArcGIS Online tools. And really, even further, that Esri data model is based off of other open standards. So if you back into it, there's OGC standards, there's Apple standards. They're all pretty related and pretty easy to make interoperable. And then they can be expanded upon. At the core, this indoor mapping is really just a data model that you can add fields to, add attributes to, depending on your use case, and expand and really make your own for your own use case. There are standards on accuracy, there needs to be standards on accuracy. There are some guides from like this ISO 196, I think it's 650. I think I wrote that down wrong. it's a BIM standard that has been in the AEC industry a while. That translates really well. And then the standards that I'm trying to push are when we collect for a certain building, that we need to document how that data came to be. Were we collecting that data for a really engineering grade use case, or what's the confidence we have with the accuracy of that data? We don't want to go down the road and say, hey, we got this great building model, but a lot of things are off just because we don't know the data. So that's really important. And then kind of along those same lines, it's you don't have to start at zero a lot of times. There's more and more data going into OpenStreetMap. If you're working with different clients, sometimes they already have data mapped or in a 3D standard. We do a lot of work with airports. Airports, all right, let's try to find data. Like the United and the American Airlines apps have indoor mapping data. There's different parts of different companies and businesses that could be using indoor mapping and you don't even know. So it really helps to ask around. Like I said, scalability has been one of my big passions recently. When we look at a jurisdiction 911 level, kind of that asking around plays into the scene a lot. So MSU, Michigan State University, does great things with indoors. But how do you get that data into the hands of the people that need it for like 911 and fire? And so creating those partnerships. Different vendors are doing different things in a lot of states. So in the geospatial world, there's a lot of people doing indoor mapping for PDFs, and PDFs are deliverable. This is it serves a purpose for the people for their buyer, their target buyer. As geospatial professionals, I like GIS data. I always want more. I want to be able to attribute. I want to be able to update. And so there's a lot of talk about this specific use case. What we can do with that data, how can you kind of turn existing data into GIS data, and then how can you make that actionable? So these are things that a lot of states are looking at on a statewide level. The GIS community is really wanting GIS data from indoor mapping efforts. And so this is something to be aware of. Same thing, other scalability lessons learned, like I said, that private partnership or that private-public partnership, working with the building owners to have either a workflow that makes it easy to update the data over time. If there's a change, maybe once a year they tell you. Maybe you can extend tools to them on how to do that. And then what are their use cases? So there's always kind of that feedback loop. And then again, the collection technologies. So we're getting faster and faster with deep learning and some AI on the front side. Being able to collect 300,000 square foot building in less than 4 hours is pretty fast. But as we get more use cases, the industry is going to grow. And so I wanted to open up the questions here. There's my email, my contact information. If you guys have any questions about more than just public safety, I mean, that's what my role is now. But public safety serves everyone. And I have a lot of experience past that market and deriving some of these use cases. So I would love to talk and hear about any of it.
Thank you, Matthew. That was fantastic. I don't see any questions in the chat. Does anybody want to come off mute? Does anybody have questions for Matthew? Go ahead, Mark.
Hey, Matt, really interesting presentation. I actually saw something similar, God, like 2 decades ago. MIT facilities manager gave a presentation on how they had gone through and mapped all of their buildings and how effective it was to classify something as a classroom versus a closet versus utility storage. And they talked about just how amazing it was for their facilities operations. But one use case which I thought was kind of interesting that I would share and want to hear more about if you've done anything like this. They were in the process of building a new building, and they were putting in parking, and parking was going to be underground. And because MIT had mapped everything in 3 dimension, they were able to place the new parking garage in its correct location, both how far down it was going to go if it intersected with utility lines, but then also create a 3D model of it. And then they immediately saw that it broke the sight line of like the president's view out of his office. And the project was immediately canceled, which was kind of interesting and moved over kind of thing. So I don't know if you've done anything like that where they've been, now that you have all this amazing 3-dimensional data of buildings, has that moved into site planning as well and sight lines? And are we about to stick an ugly building in the middle of like something really nice or stuff like that?
Sure. Yeah. The volumetric space planning is definitely a hot topic. It's pre-existed indoor mapping per se a little bit on the exterior, but now with indoor mapping, we're getting into actual like view sheds of specific windows. So much so that there's real estate companies and people out there doing like the value of your view, because you have these three-dimensional buildings, you know where every window is and what one goes to what unit. And so like in New York, what can you see out of your window? That's all geospatially able to be derived now, which is pretty cool. Your universities use indoors a lot. There's amazing use cases, everything from campus-wide like routing for work orders and stuff like that. I know a university that saved like hundreds of hours of emptying empty trash containers, because they rerouted their maintenance people that empty the trash, and then they overlaid their classrooms and when they were occupied. And so they could see a geospatial analysis like that. I've worked with a lot that do like ADA routing. And so your parking garage use case kind of was interesting on that level, where yes, things like being able, before it gets to an engineer, kind of on the site selection and in really early planning, you can go down the route of saying, hey, what are grades and how does this affect our ADA strategy? How are people going to route to it, and do some of those kind of analyses?
Yeah, and that's super important. My wife broke her foot a couple months ago, and I very quickly learned what I thought were ADA compliant buildings were technically, but you need to go around the back to the elevator to that, and like it's just terrible design. So yeah, that's super important. So I also saw something when you talked about, New York City. It sparked a memory. I used to work in New York City. New York City modeled out a dirty bomb, and they figured out the radiation penetration levels into buildings based on material type and 3 dimensions. So if you were in the center of the building, you were further from the radiation than if you were on the outside, kind of modeling kind of thing. Scary, but also kind of interesting too.
No, I think that's a great thing. We're getting, I know with our product, we're getting a lot of interest from like SWAT to put that attribute data on the actual assets. And so is that a steel door, or is that a wood door? Is it a hollow core door? What are these walls made out of? Just simple things like that you kind of overlook, but it's really easy to store in geospatial indoor data. And then they get it into their hands, and it helps them in their mission.
Yeah. Cool.
Well, thank you very much, Matthew. We are out of time with our meeting, so we'll go ahead and adjourn at 12:03. If folks have items for the next agenda or anything you'd like this group to discuss, please email me. Our next meeting will be in January of 2024. Have a great day, everyone. Thank you.
Thank you.